Alright guys, question number 33. Let's change it to blue. My favorite color, by the way, if you guys care. For each of the graphs, select all symmetries that apply. So, graph A, and I'm going to zoom into that. We want to see if it's symmetrical to the x-axis first. Remember, symmetry is like a mirror image. So this is your x-axis. Matter of fact, let's not even use that. Let's use yellow. And let's use a highlighter actually. Yep. This right here is your x-axis. Does the top half mirror perfectly, exactly, the bottom half? And the answer to that question is no. The top half does not mirror the bottom half. That's why it is not symmetric with respect to the x-axis. Now, we're going to test the symmetry with respect to the y-axis. Change up my highlighter color. Let's make that blue. Let's draw a line down the y-axis. Does the left half of my graph perfectly mirrors the right half of my graph? It doesn't. An example of that, if I go here, put that to black, I have a point right here. For it to be a mirror image, that same point will also have to be right here. That is not the case. Therefore, that is not a symmetry with respect to the y-axis. Now we're going to try the origin. Change up my highlighter color again. Let's use red and make that less thicker. When it comes to the origin, you're going to draw a dotted line through the origin. The equation of y equals x. Actually, I'm not going to use a highlighter in this case. That's too bold. Let's use a pen. Okay. All right. When I draw my ugly drawn dotted line through the origin, does the top part of your graph mirror the bottom section of your graph? And the answer is yes. The answer is yes. I'm going to place a point right here. If it is symmetrical with respect to the origin, that same point has to be in the same spot. And that same point is also right there when I look at its symmetry, and vice versa. Because remember, we're drawing a dotted line through the origin, which is a diagonal reflection. And the answer is yes, there is a diagonal reflection. Once again, I'm going to place another coordinate. I'll place a coordinate right here below the dotted line, which means if I reflect that over my dotted line, the same coordinate will also appear right here. And because that holds up, that is going to be symmetry with respect to the origin. So only that symmetry applies. So take a good look at this graph. See how it's drawn. Remember that. Because on your exam, if this question appears, and you see a graph like this, that is going to be symmetrical with respect to the origin. And this graph right here is known as your sine graph from trigonometry. Sine graph with an amplitude of 3, if it looks. Okay, let's transition on to the circle. Symmetry with respect to the x-axis. I'm going to draw a highlighted line through the x-axis, and I'm going to ask you if the top half mirrors the bottom half. And that is true. Yes, the top half mirrors the bottom half. If I'm able to reflect that over the x-axis, let's put a point right here. Over the x-axis, that same point will be a mirror image to the point that is right here. All right. Now let's focus on symmetry with respect to the y-axis. Put on my highlighter once again, make that yellow, delete everything on this graph. Okay. We want to see, does the left half mirror the right half? And the answer is yes. The left half is an exact reflection of the right half. For example, if I put a point right here, that same point reflected over the y-axis will also be right here in its same position. Therefore, yes, that is a mirror image. And I want to say this. If your equation, if your graph is symmetrical to both the x and the y-axis, by default, the graph is symmetrical to the origin. I'm going to say that one more time. If the graph is symmetrical with respect to the x-axis and the y-axis, by default, the symmetry also applies to the origin. If I draw a dotted line through my origin, the equation y equals x, the top half of my diagonal mirrors the bottom half of my diagonal. That is symmetrical to the origin as well. Alright guys, let's move on to the last one. C. Is this symmetrical to the x-axis? The answer is yes. If I draw a line through my x-axis, the top half of my graph mirrors the bottom half of my graph. So yes, respect to the x-axis. Let's erase. If you look at respect to the y-axis, does the left half mirror the right half? The answer is no. The function is only drawn on the left half. There's nothing on the right half. There's no respect to the y-axis. Let's examine the origin. Draw a horizontal, a dashed line through the origin. Does the top of the horizontal line mirror the bottom of the horizontal line? The answer is no, because once again the function is going to be sketched above the diagonal line. There is nothing below the diagonal line, so there's no symmetry with respect to the origin. It is only going to be the x-axis, and if the symmetry didn't apply to none of those, then it'd be none of these. Alright guys, I know this is an 8-minute video, but I wanted to really ram that in so you guys understand it. I hope it made sense to you. I'll see you soon.